Then how do we go with solving this problem? The first thing we will do is that we will determine the earth pressure coefficient. And I taught you in class before now that earth pressure coefficient can be determined using the Rankine method or using the Coulomb's method. And when you use the Rankine method, you don't consider the friction between the wall and the soil. So you assume that the wall is frictionless. And this is what we call a conservative design, because now if there is friction between the wall and the soil, it's going to add more resistance to sliding. But just imagine when you are wearing a shoe that does not have teeth, that does not have friction, it's easy for you to slide. But if your shoe has friction, it will be more difficult for you to slide and fall. Now, you can see we are using the Rankine method. Now we will have, this is the formula for determining the value of the lateral active pressure. So we have the passive earth pressure, we have the active earth pressure. And in class, I explained to you clearly what the passive pressure and what the active pressure is all about. And I said it doesn't just mean the soil in front of the wall or the soil behind the wall. We are saying the passive pressure is the pressure that is resisting. So when you want to push into the soil, there's the pressure that wants to, you are pushing the wall into the soil. The soil there outside, when you are pushing the wall into the soil there is going to be having, the soil in front will have a resistance, it's resisting the lateral movement. Now, but when you are compressing, you're trying to compress laterally, causing internal shearing resistance along the potential failure surface. So you are going to mobilize shear strength of the soil. Let's go just solve this problem so we will not have to get a lot of confusion. Solving this problem is simple. You have to know this formula. This is a formula to determine the active earth pressure. For this question, we will not determine the passive earth pressure. And why? Because we are trying to be super conservative. And being super conservative, the passive pressure would have added to the more resistance of the wall. But because we want to be super conservative, we will use the active, and the active is the one that is causing the wall to collapse. Now we have this formula. You are going to use, remember that the value you are going to use here is 30 degrees, and the 30 degrees is the frictional angle of the backfill soil. You put this thing, punch into calculator, you get this value. And now when you are done with this, you determine this value. Now is the same thing as this when you go down to solve it better. Then the next thing is you use the Coulomb's method. Why are we using the Coulomb's method? Because part of the question says that now if the wall has a drainage, and first of all you are asked the question, determine when there is friction. Question number A, determine when the wall is frictionless. You are going to use Rankine method to determine the earth pressure coefficient. But the question number 2 says, determine when there is a friction, adhesion between the wall and the soil is 20 degrees. You are going to use the Coulomb's method. That is, only difference between the two questions is the method for the determination of the earth pressure coefficient. That is the difference between the two methods. The two questions. One, the first question says, determine this value when there is no cohesion between the wall and the soil. The second question says, determine this value when there is cohesion. And the only difference is the methodology for determining the earth pressure coefficient. So the second one, you can see here, these are the values. We don't the formula is this. This is a formula for determining the earth pressure coefficient. We just plug in these degrees here. These values stand for the adhesion between the wall and the soil. Then these particular parameters were not given to you, So if you plug this into this equation, which I already gave you in your notes in your class, you could check up in the textbook, you could see this this value, this equation. So when you plug it into this equation, you will get this value, 0.3. Now this is the value for the earth pressure coefficient using Coulomb's method. Now once you've done this, you move to the next part of this, which is determine the lateral forces, and it's a simple formula for determining the lateral forces. Now if you multiply, I know that I derived these things in the class before I traveled. So if you go on, you can determine this, you know this formula already, which is if you multiply the earth pressure coefficient by the unit weight of the soil, multiply by the square of the height, you can be able to determine the lateral force. So we don't need to go to defining. I'm tempted to go to define, explain how the formula is gotten, but to make the video so long and it might be boring. So make sure you know this formula, because in the exam it won't be given to you. You have to know this formula, know the parameters there, know why the parameters are there, so that you don't have any mistake. Because if you make any mistake there, that will be that all the things you'll be solving will be rubbish. So you plug in this. Remember that this particular one stands for the unit weight of the soil, which is this parameter. So the second one here stands for the height of the wall. This is this per value, unit weight of the soil. This is the height of the wall. This is the lateral earth pressure coefficient. This is the resultant. So you are saying what resultant is the force acting? Is acting 1/2, because it is acting horizontally. So now you go to the next part. The force acts horizontally because of the ground surface. So you can see it here already. Again, you see the Coulomb's method is the same formula, but the only difference between the Coulomb's method and the Rankine method here is the methodology for determining the Ka. So the only thing that changed between this equation and this one is this. This value is the only difference. So you see, it's not difficult for you to solve this. It's not very difficult. It's just for you to know, okay, first thing is determine the active earth pressure with the two methods. Once you determine it with the two methods, the next thing you will do, determine the lateral forces. And the formula is this. So the difference between A and B. So when you are solving this question, you're actually solving option A and option B together. Now, this force acts now for the Coulomb's method. For you to determine the actual horizontal force, you are going to resolve the force, because now when there is a friction between the wall and the soil, and the friction acts at an angle of 20 degrees to the horizontal. So that means you're going to determine the force in the Cartesian coordinate. You're going to determine the vertical force. You're going to also determine the horizontal force. So you're going to resolve this in the x and y direction. So how do you do this? So you are going to multiply 9.81 multiply by cos 20. You will resolve it to the horizontal component. If you do the same thing with cos, you will resolve it to the vertical component, and that will be that will be the end for determining the lateral forces for the Rankine and for the Coulomb's.